quick background. So BetterCloud, we've been around for about 3.5 years. We left this company called Cloud Sherpas. They're the #1 Google Apps provider for a company going to the cloud for email and collaboration. 8 of us left that company and started BetterCloud. Cloud Sherpas did services, we did product. We've been #1 in Google Apps Marketplace since we launched our product. And our vision has expanded quite a bit. Now, instead of just focusing on Google Apps, we're also looking at Office 365, because any company that's going to be going to the cloud for email collaboration, we believe that those are going to be one of the 2 providers they're going to use 99 times out of 100. We're big, so I mean we have a lot of data. We have, as Amit we'll talk to, we have currently for just our Google Apps product, 90 terabytes of data. 50,000 companies have installed our product, representing 30 million users in a lot of countries. And the reason we have so much data is for every one of those users, we're going through and getting the metadata for their docs. There's Google Sites, their calendar, secondary calendar, Google Plus posts, third-party apps that get installed. It's just a lot of data. We're hiring developers. We do development both Java and C#, leads, DevOps.
Hey guys, so since start of the company, we started off with the App Engine storage, App Engine data store, and that's where we started. But at this point of time, we are at a step where we are seeing around 90 terabytes of data, and of course that's not really cost efficient at all now for us. So we started researching on some of the other data tools which can be cost effective for us, and that's where we landed on to the open source Apache Cassandra. That's where we started our journey on Cassandra. The primary CTQs of moving on to Cassandra were we definitely wanted linear scalability without any compromise on the performance. The same performance that we got out of the App Engine data store, we also wanted the similar performance on the Cassandra. And also, being worldwide, we also wanted a multi-zone and multi-region distribution of the data. Since we started with Apache Cassandra, there were certain issues, not issues, but there were certain challenges that we started facing. One of the major challenges was ramping up the developers, ramping up each and every person across the team to know what Apache Cassandra is and getting them up to speed. So the documentation, which is provided by DataStax, it's excellent. And we went through all the videos and had the sessions with the developers to ramp them up, and we are good to go. So that's where we are right now, and we are in production already with Cassandra, and we are good. Another challenge that we started facing was moving from the RDBMS background onto the Apache Cassandra. How should we model the data sets that we have, and how should we retrieve them successfully without any issues and without any performance issues at all? So at that point of time, when developers without any knowledge started working with Cassandra, they started creating indexes directly onto the tables on which the keys were not present. But that was not a good idea. Performance started coming down, and then we remodeled the stuff, and that's where some of the lessons learned, and we went into those things. The major challenge when we started move to Cassandra was while using the App Engine data store, we were able to index the data properly. We were able to retrieve, we were able to add the filters, we were able to sort them effectively in the App Engine data store. But when it comes to Cassandra, we cannot really do a search on any column in the table, and that's where the need for indexing arises. And we started facing that challenge over there. The first option that we tried was maintaining the index tables. For example, just have one more replica of the table, push all the indexes onto that table, and then by retrieval, just pull that indexes and then retrieve the corresponding data set from the other transaction table. But then that became more complex from the design strategy standpoint, and then we started looking for better options. Of course, secondary indexes was again an option, which we are using definitely at this point of time, but only for certain use cases, like for Boolean fields, we are using it definitely. It performs much better when it goes onto the Boolean fields. But the only change while we switched onto the indexing for the Boolean fields was we are not storing the true values anymore, because our use cases was that we only wanted the indexes, or we only wanted the values with the false. So we are not storing the true values at all, we are just storing null. So null means true over there. So that way it reduces the indexing, CPU usage, because Cassandra does not really index null values at all, so you don't have to worry about it. It just indexes the false values, and we are good to go. The third part, we went ahead, and that's where the need arose for the ad hoc querying and indexing. Like, we wanted each and every filter, each and every column to be filtered upon, and we wanted some solution to be in par with the DataStax Enterprise with Solar that they provide, but we wanted to stick to open source, and that's where we started researching on certain distributions. Like one of those were Stratio Cassandra. So Stratio Cassandra, what it does is it basically writes all the indexes onto the Lucene indexes, and posts those Lucene indexes into the same host of the Cassandra. So it, unlike in Solar, it actually maintains the indexes onto the Solar nodes. It does not really do that. It posts the indexes onto the individual Cassandra nodes itself. So the write path goes in this way: is whenever you hit a write onto Cassandra, it first writes onto the Cassandra data store. It uses the custom secondary indexes path to index the Lucene files, and then by retrieval mechanism, it first pulls off the Lucene indexes and then pulls off the corresponding data. So that's how it works. And the best part of that was there was one single write path and there was one single read path via SQL. So you can basically read all the columns, filter on all the columns that you want to directly from the SQL by having the Lucene search queries as part of the SQL itself, and you don't have to worry about anything else. The only major challenge with Stratio Cassandra was it was part of the distribution itself. That when I mean to say part of the distribution, they had their own distribution to be used up. So there was no way in which you can go with the open source of Cassandra and use Stratio with it. So that was not a good solution for us. So we went ahead and we saw that there is one more solution to it. It's called a Stargate by Tuplism. What that does is, it does a similar pattern what Stratio does, but it maintains different libraries. It creates jar files of its own, and you can just use those jar files as part of the library folders in Cassandra and use your own custom indexes to again create the Lucene files of it and then retrieve it effectively. So that performed better, and we are very happy with it. We did some of the performance tests. It passed all those performance tests. It's pretty good. But when it comes to a distributed nature of the large amount of data, we definitely want some system which would host the indexes separately and the data separately onto Cassandra. So, like an example, just like DataStax Enterprise does, it hosts the Solar indexes separately onto the Solar nodes, and it hosts the data onto the Cassandra data nodes. So that's where we started doing some kind of proof of concept onto why can't we create our own in-house custom indexing. so that whenever you do a write onto Cassandra, it should ideally write directly onto the queuing mechanism, like Kafka or RabbitMQ or any such queues, or probably directly to Elasticsearch. So that's where we started researching upon, and we went through those libraries, we saw what they have done, and we read the documentation on the custom indexing on how we can do that. And at this point of time, we are pretty much hopeful that we could do, and we would do it for sure. At this point of time, we are already completed with the development, and we are successful in writing back to Kafka directly from Cassandra. So the write path would not, means you would not need to write 4 writes, one to Cassandra and one to Kafka. You just have to write it to Cassandra, and it would basically push it onto Kafka, and then you can use it onto Elasticsearch or Spark Cluster or anywhere you want. So that was a pretty good research. And, yeah.
You wish you could have just directly used Elasticsearch instead of Cassandra, based on your requirements you selected. You could have used Elasticsearch as a database.
That was a possibility, but still, if you really see from the availability standpoint or the data storage standpoint, Cassandra goes into a very, very stable environment as compared to Elasticsearch or treating Cassandra as a data store and treating Elasticsearch as a data store. There's a huge amount of difference.
So it's not very stable?
Yeah. Maintaining it as a data store, it's not really stable as compared to Cassandra. Some more challenges, learnings, and facts around our journey onto Cassandra. So at BetterCloud, we tend to do the test-driven development, and it's basically acronym test TDD, and have the integration tests in place on the data services there, so that whenever the data model changes, you must ensure that all the changes that are taken part of the data model, all the integration tests should be successful, and then you can go into those. So it really helps us to effectively alter our data models frequently and move forward without any disruption due to the issues that we can face in the staging environments also. So it's a good thing, for sure. One more thing that we as BetterCloud wanted to do was, being a multi-tenant application, we also want to track each and every tenant level metrics onto what is the number of seats that is there for every tenant, or for every customer or tenant. Then what is the usage of the application onto the tenant level? Then what are the different levels of metrics? So we started tracking on those metrics as well from Cassandra, and that's what we are doing right now, and doing some proof of concept on how we can do those things. And the last thing that the challenge we faced from the C# standpoint was the prepare and the bind statements that we're using for fetching out the connections. It returns actually an object and does not really return an interface. So it's not really helpful for us. So our C# update, who's sitting over here, he has developed his own code, and he's going to fork his contribution to the GitHub. Probably, let's see what it does. So it's being an open source, it definitely helps to keep track of those things and go forward. So here is an example of one of our entities. It's basically the user table that we use. And for example, the tenant ID is basically it supports the multi-tenant structure that we have. And the clustering key, the way we use the clustering key is because all the ordering depends really on the clustering key. We always wanted the default order to be part of it, and the clustering key text as a data type actually holds the concatenation of strings of the user ID and the display name. So it automatically sorts all the data sets onto the display name first, in ascending order, and then uses the object ID for the filtering mechanism, which makes it unique. So that's how we are using as part of the clustering key, and it helps us to maintain the order. And then, as I said earlier, we are using indexes onto the Boolean columns for fetching certain data sets based upon our use cases. Like, for example, we want to see how many users are enabled, or we just wanted to list out the users which are enabled as part of the alerts. And those Boolean level indexing really helps us